We're going to open an AutoCAD.dwg file into Autodesk Simulation Mechanical. Once the geometry is in Autodesk Simulation Mechanical, we can define what sorts of beams we have. There are several standard configurations, or we can use an AISC library. If we choose an AISC library, we can choose the type of section and have the program read in the cross-section properties. We can then go into the analysis parameters for a natural frequency modal analysis and tell the program how many modes we would like to calculate. In the results of a natural frequency modal analysis, we can view those mode shapes as well as animate them. Now that the natural frequency modal analysis has been completed, we can perform other types of dynamic analysis, such as response spectrum. The response spectrum input is either displacement versus period, acceleration versus period, or G versus period. Once that data has been input, then we can calculate the maximum displacements and stresses due to a spectrum type of load input. Here in a results environment, we can see the worst stress for a given frequency and a particular load case. There are convenient buttons for you to move backwards and forwards and investigate the various load cases that have been solved for. Alternatively, we can go to the results options and take a look at the resultant stress. In the results environment, we can also change the display in several different ways. One of those is to go to View, Visual Style, and we can turn on Shaded with Mesh. Likewise, we can add slice planes into a model so that we can interrogate just the portion of the model which we want to observe. Looking at half the model, we're going to take a look at the various types of displacements, stresses, or safety factor. It should be noted with the safety factor that the user can enter an allowable stress on their own or load the yield stress or ultimate stress of the material. So taking a look at safety factor, we can also go into legend properties, range settings, and we can utilize the threshold command to show elements on the model that are above or below a particular value. With this, we can find areas of the model that need to be strengthened, or where perhaps the model can have material removed from it, thereby saving us some costs. One other feature of the software is the ability to go into the report and configure the report so that you can define title, project name, who the author is, and include an executive summary. In addition, you can see inputs to the analysis, such as elements, materials, loads, and constraints. You can export to various formats, and you can also include images and graphs into your report. Another type of dynamic analysis is frequency response. In frequency response, in the analysis parameters is where the setup is done. On the Excited Nodes tab, we can define what nodes are going to be subject to some sort of acceleration input or force input. On the Excited Frequencies tab, we input what frequency we want to excite the structure with. On Damping Ratios tab, we can include damping into the analysis. You can also open up a CSV file to input damping versus frequency data. Finally, on the Amplitudes tab, we tell it what the acceleration is at a given frequency or the force. In frequency response, we calculate the steady state response, displacements, and stresses due to a harmonic or sinusoidal load. Last type of analysis we're going to look at is random vibration. So in random vibration analysis, the input is either acceleration squared hertz versus frequency or g squared hertz versus frequency. Once that data is input, the program will calculate the statistical response of a system, that is, the displacements and stresses, due to a random vibration, white noise, or power spectrum density. Here in the results environment, you see that we have access to all similar results types that we had prior. That is, we can investigate the displacements, the von Mises stresses, and safety factor. Please also note that in this type of analysis, as well as all others, you can also still access the report as well.